This lesson is on exponents and division. It goes on IN page 63. Your reference pages are pages 203 to 207. When you think about exponents and division, one of the things you want to remember is what a fraction of 1 looks like. 3/3 is a fraction of 1. Y over y is a fraction of 1. 4,000 over 4,000 is a fraction of 1. 9 over 9 is a fraction of 1. All of these are fractions of 1. And when we go to divide exponents, then we need to think about fractions of 1. So here's a rule. To divide integers with the same base, you subtract the exponents. So this is 10 to the 5th power over 10 squared, divided by 10 squared. So that equaled 10 to the 3rd power because we subtracted the exponents. 5 minus 2 is 3. And you can look at it that way. 5 minus 2 is 3. But I want to show you a visual of why that is. We've got 10 to the 5th power. 1, 2, 3, 4, 5. And we've got 10 squared. 1, 2. So we make these fractions of 1. 10 tenths is 1. And another 10 tenths is 1. And you know, we don't generally write down ones. So that leaves 10 threes left over on top. Where they are on top, whether they're on top or the bottom is going to make a difference, which I'll show you in just a few minutes. Here's something that you should remember. 3/4, 3 to the 4th power over 3 to the 4th power is a fraction of 1. So 3 to the 0 power, any integer to the power of 0 equals 1. Okay? It's not 3 to the 1st power equals 1, but 3 or any number to the 0 power equals 1. And you can see that that would be a fraction of 1. So therefore, it would equal 1. Now, sometimes the denominator is larger than the numerator, and so you get a negative exponent. Here's an example. 5 to the 6th power divided by 5 to the 8th power. So we're going to make 6 minus 8 is going to equal a negative 2. But they don't like you to write 5 to the negative 2 exponent, or negative square exponent. Instead, they have you write 1 over 5 squared. And you drop the exponent, which equals 1/25. This is important to remember. If the answer is negative, write as a fraction. 1 is the numerator, and the power in the positive, not the negative, is written as the denominator. So our answer was negative, so we wrote it as a fraction with 1 is the numerator, and 5 with a positive square, 5 squared, as the denominator. Now, sometimes you're going to have exponents with mixed terms. And so we're going to go down and look at that. This says 3y to the 8th over 9y squared. Then that's when you need to look at like terms. We know that 3/9 is like terms, and these y's are like terms. So 3/9 could be, their greatest common factor would be 3. It would be 1/3. 8 minus 12, it would be y to the negative 4th. So we already have a 1 at the top, so we don't need to add another one. And so it would be 3y to the 4th. Because remember, as we looked at earlier, the 1, a negative exponent is written as a fraction with a 1 on top, with the 1 as the numerator. So this works out the same way. So look at it one more time. 1/3 y to the negative 4th, but we leave the 1 on top and just put y to the 4th, 3y to the 4th on the bottom. Pause the video right here. Okay, so now we're looking at page 206, 1 through 10. And the first one is 2 to the 5th power divided by 2 squared. So it'd be 5 minus 2, and it would equal 2 to the 3rd power. Now, if it is a if it's an exponent that you can work out, 2 times 2 times 2 is 8, they expect you to go ahead and write 8 there. The next one, h to the 6 minus h squared. So that would be 6 minus 2, which would be h to the 4th, which we don't know what h is, so there's no way for us to find out what it is completely numerically. Now we have 6y to the 7th, 10y squared. Remember that we have to look at each of these in their own like terms. So if we looked at 6/10 first, we found the greatest common factor to be between 6 and 10 to be 2. So we divided both the numerator and denominator by 2. You should have gotten 3/5. And then 7 minus 2 would be 5. So that would be y to the 5th power. So it would be 3y to the 5th over 5. And that would be the correct answer for that one. Now let's look at number 4, because sometimes it gets harder when you have all of these variables and exponents. So the easiest thing to do is to make sure that you're putting things in the right place. We did prime factorization. So I've got 1, 2, 3, 4 m's and 1, 2, 3 n's, and then 1, 2, 3, 4, 5, 6 m's and 2 n's. Then I started making my fractions of 1. And what I had left over was n on the top and m squared on the bottom. I didn't make it a negative square because I have 1 n on the top. Okay? Now let's look at number 5, and it says -4 to the 0 power. And remember that this is not the opposite of -4. It is -4 to the 0 power. And so the answer would be 1, because anything to the 0 power is equal to 1. In the next one, we had 10 over 2 b to the 8th, b to the 8th. Well, b to the 8th, b to the 8th is 1, so we just took that out. And then 10 divided by 2 is going to be 5. In number 7, see if we can get the rest of them, 7, 8, 9, and 10 in view. In number 7, we had m squared divided by m to the 6, so it was 2 minus 6, which would be m to the -4. But again, we don't like negatives, so we converted it to 1 over m to the 4th power. With 2 to the -3, you need to convert it to 1 over 2 to the 3rd power, or 2 cubed, which would equal 1/8. And finally, number 9, we separated these into their like terms. 4/20, its greatest common factor was 1, so we did 1/5. And then we did a, and so that would have been a -3 on the bottom, but we had a 1 on the top, so we just made it a to the 3rd power. If you look at 10, our last problem over here, x to the 5th and x squared. So x to the 3rd was left here, and this would have been y to the -5, but because we had a 1x on the top, we just made it y to the 5th. Okay? If you have any questions about this, you can come and see me tomorrow. This does get difficult, so I will be there to help you. And we'll be doing page 206 and 207 tomorrow in class. I'll see you then.